Okay, folks, let's get back to it. So I might as well titled this section, "Do you still want to collect digital trace data?" Given that we've just gone over how many limitations there are. So we're gonna work through a few basic techniques for collecting digital trace data, and we are going to then move on to what I hope is a solution to many of the limitations of digital trace data, which is building apps to collect digital trace data. Okay, so before you set out to collect digital trace data, I almost always encourage people to ask whether you need to do that. On the one hand, it's not that hard often, but on the other hand, we have amassed a pretty large amount of data from digital trace sources like Facebook, Twitter, news sources like New York Times, Reuters, Google, Wikipedia. Here is a list of crowdsourced data sets that I curate. I would be overjoyed if you share any additional ones that you know of. Right now, there's I think only about 50 data sets on there. But I just thought this would be an interesting collective resource for folks who are interested in checking out the data. Second, ask yourself whether you could supplement or expand upon someone else's data set before you collect your own data. And I think that's a really nice solution because there's opportunities to repeat data collected at an earlier period or across another platform. We saw how nicely that worked out with the Macy talk last night. Being able to validate a theory in multiple settings is always better. Though some types of digital trace data collection are pretty straightforward, others are extremely time-consuming and coding intensive. So check out that list when you have a second and think about whether you need to collect your data. But in many cases, people are still going to want to collect their own digital trace data. How do we do that? So basically, I think we have three general approaches. The first is some type of prepackaged data. A lot of that is listed in that Google sheet I just linked to. But we also have a variety of prepackaged data like Google Trends. So you can go to Google Trends and download a CSV of the relative increase in search volume for a term across usually the last 10 years given sufficient search volume and across different geographic areas. And there's various strengths and weaknesses to those data. The second kind of big picture way is to screen scrape in one way or another. We're going to work through a quick example of pulling data from a Wikipedia page. We're also going to talk briefly about browser automation as a way of collecting large amounts of data in an iterative manner from a website, and also crowdsourced, what you might call crowdsourced scraping. And finally, we'll get into APIs, application programming interfaces. And I'm gonna argue that these are probably our best bet for getting data for a variety of reasons. First, let's start with the kind of historically the most popular method for collecting digital trace data, screen scraping, which refers to a computer program that loads or reads in a web page, often an HTML document. It finds some information on that page, it grabs the information, and it stores it in some type of data set or database. So once upon a time, this was great. When I was first getting into the field, early days, 2006, 2008, it was the wild, wild west. You could scrape anything. And indeed, researchers were left and right scraping everything. Many of them published papers with these data. Others eventually got shut down for violating terms of service. That is the rules every website has that determine what you're allowed to do on the website. If you're curious about learning what the rules are for a particular website, you can visit the text robots.txt policy, which describes what type of automated data collection is allowed on a page. We are no longer in the wild, wild west of the internet. The overwhelming majority of pages have taken very intentional steps to prevent you from screen scraping, or have a very complicated structure, again, often intentionally by design, that prevents us from automatically scraping data. There's also real important questions of data ownership, and to the extent that data has become valuable in especially Web 2.0, we're seeing that screen scraping is becoming harder and harder. Screen scraping, I also want to point out, is now against the law in many sites because of these policies. And I want to point out we kind of touched on this with ethics a little bit yesterday. I want to note that you're not only in a gray area ethically, but you may also find yourself in the awful situation where you've collected data for multiple years and then you get a cease and desist letter that ruins your dissertation or your tenure project or your postdoc project, right? That's the absolute worst case scenario. Then you literally can't use the data that you've spent years collecting. I made that point. So let's work through a simple example. We're going to get into the code a little bit. This is just a page from Wikipedia, which describes World Health Organization ranking of health systems. So if you open this link, you'll see this page. And let me say first of all that Wikipedia is a site that is intentionally offering information, and so it's rather generous in its sharing of information. Another thing that's really advantageous with Wikipedia, though, and by the way, we could get data from Wikipedia in many other probably better ways, but just for the sake of argument, let's work through this example. The other thing to note about Wikipedia is that it has a very consistent structure, right? So I always have a title here, the summary is always here, the help links are always over here, and so any piece of information is presented in a consistent format, which makes it easier for us to code around that, because we simply say if we have a list of pages we want to scrape, we go to each page, we look for the same part of each page because it's named the same way, and we can find that part of the code that we're trying to scrape. So we can see that structure here, but of course what a website looks like to a computer is much different. This is the source code from that HTML page, from that web page. And HTML is a way of telling a browser how to represent some information at root. And so screen scraping typically involves loading in HTML into whatever coding language you prefer, and then finding a way to find the piece of information on the page that you want hidden in this mess of code. And you can see the source code of any HTML page if you're in Chrome, for example, by visiting the Developer Tools tab. So let's say on that page we want the info from this table. There's a useful tool in the Developer Tools frame, drop-down menu within Chrome, which is Developer Tools. And when we turn that on, we have this useful kind of widget that shows us the page itself up here, the HTML code, and when we mouse over any part of the HTML that we want to find, it's highlighted in our HTML code. And that helps us navigate and find the part of the HTML where the data we want lives. Specifically, often we screen scrape by using one of two parts of the code. One is called the XPath. The other is called the CSS path. To find the XPath, once you've highlighted the part of the code that you want to scrape, if you right-click, this is a Chrome-based example, but there's analogs in Firefox. Once you right-click, you can select Copy XPath, and then you'll get a little snippet of text that will help you write a computer code that finds that piece of the page that you want to scrape. So let's say we're working here in R. We set up our working directory. This is where we're going to store any data we collect. We're going to install a package here. This is the Rvest package written by the legendary Hadley Wickham. This is actually porting over, Python users will be familiar with the beautiful soup package for screen scraping. This is basically an R version of that package. So those of you who have only come through the data camp packages, you've probably installed one package. Just a reminder that in R, after you install the package, as in Python, you have to load the package, or in the case of Python, a module, to tell R that you want to use the code that's in that package. Okay, oops, sorry, I'm going backwards. Okay, so grabbing the HTML, Rvest, and many other packages like it has a function that allows you to read in HTML from a web page. In this case, the Rvest function is called HTML. We simply pass the URL that we want. This is the one I showed you earlier. We enclose it within parentheses. Sorry, I'm having some text wrapping issues here. That should wrap around. But this ends with ending the quotation marks and the parentheses started there. And now, if we browse this object that we've created using the HTML function in R, we can see what we saw when we used the developer tools in Chrome. We're seeing the HTML, or actually in this case it's XML, a slightly different format. So now we have all that messy text, and now usefully we can get through these data using that XPath, which is that snippet of text. Here it's this jumble of text here, all this text here. And what this allows us to do, so most web pages have a tree-like structure. So we go from that big mess, and then there's branches on the tree, and information that we want lives on one branch on the tree, and one sub-branch, and one sub-branch, and so on and so forth. And these are often called nodes, which is why this function here that helps us parse this HTML is called HTML_nodes. And we pass an argument in our function here, XPath, after the object we created in the previous step, Wikipedia page, and we create a new object, which is the section of the Wikipedia page where the table that we're trying to scrape lives. And then we see we've created another object. And finally, within that node, the Rvest package has another function which lets us extract any table structured information, and that text that we're looking for is a table in that it has rows and columns, and we get our health rankings data. If we browse that data using the class function, which tells us in R which type of data, which type of object we're looking at, we see that's a list. Lists are a pain in the ass. It basically is a data format that stores multiple types of elements. They could be text vectors, they could be data frames, they could be any number of things, but they can have different lengths and different structures. So we need to extract now from our already messy HTML data this health rankings data, and we're going to do that using the data as data frame function here in R. And finally, that's how we'll get our data. If we browse that test object here, we would see a fairly neat. It would still need some cleaning up. And by the way, especially if you're following along for the first time and you've never done any of this type of coding before, I encourage you to follow along with these slides for the big picture, and then come back later and check out the annotated code, which is linked next to the slides on this section of the day. And that annotated code basically says what I'm saying verbatim in comments in .r code, and has sample data and has what I hope will be an example you can work through. This is one of the compromises we came to when we were thinking about how much to get into the weeds with coding. So this is how we get our data. Often the XPath trick, so to speak, will not work. In this case, I recommend a Chrome plugin called Selector Gadget to find the CSS within the page. This is the alternative piece of information that can be used to extract information from a page. So later this morning, we're going to grab some Twitter data, and so I was looking for a list of Twitter accounts that we might want to scrape, and this page links to the top 100 Twitter accounts in terms of followers, and it turns out that the piece of information where the CSS, which is this code text, which tells us where that information lives on this page, is called .name-bio. To find that, sorry, I'm missing a slide here. This plugin allows us, much like the developer tool that I showed you in Chrome just now, allows us to click on the part of the website that we want to scrape, then click on a part that we don't want to scrape, and each time we do that, we'll see a different code appearing down here, which is this CSS that we can then use to identify only the part of the page that we want to scrape. that takes a little practice and a little messing around. One of many reasons why screen scraping is becoming passé, especially given that most of the pages we might want to scrape are not like that neat Wikipedia page, which has a very simple, consistent structure. Most of the pages are more like this, this Twitter page here, which have not only inconsistent structure across pages, but lots of complicated structures like JavaScript, which handle what happens when we mouse over and so on and so forth. So just to work through and give you a little more code for those of you who are want to work with screen scraping. Here's the CSS we found. Here's the code you might use to extract that list of followers from the HTML that we get from that page. You'll see it's very messy when we do it in this way. We have here what are known as HTML tags. These are instructions to the browser about, for example, how many spaces to put between a name or how to display text. Of course, in many cases, the information we want is just, God knows why we want to be studying Justin Bieber, but okay, so let's say we want that Justin Bieber. We then have to use some type of text analysis, or there's many other packages in R and other languages that help you clean up HTML data and would allow you to work through to get that kernel of information that we're looking for. We want to eventually take these data we scraped and pass it to the Twitter API to programmatically collect a bunch of data from these Twitter users. So if you want to know how to clean that up, that code is on the Summer Institute GitHub page. Actually, that should say on our main page. It's hosted on a GitHub page, but that's not publicly accessible. Same thing though, it's linked right next to this section of these slides, screen scraping on Tuesday morning. Of course, most of the time, we don't want to just scrape one page. We want to scrape many pages, thousands of pages even. And so many of these commands can easily be placed within a loop or some other type of iterative coding process. One thing to note, especially if you're new to screen scraping, if you see your Python or R session telling you you're getting SSL or OAuth errors, most likely you are being, you either don't have permission to access that site, or you are being blocked for repeatedly trying to access that site, probably because you've knowingly or unknowingly violated the terms of service. So this is just code language for, oh man, I'm getting rate limited, if you don't know how to interpret these mysterious error messages you might get the first time. Are there questions about that? I went through it pretty quickly. From talking to people, I got the sense a lot of people have done this before, so I don't want to belabor it, but are there questions or other recommended techniques for screen scraping that people prefer? Yeah?
For me, this is my first step, so I passed through that yesterday night, and I just maybe need some time, if you can have some time later to work on that.
Absolutely, yeah. I think probably both of the TAs could sit down with you maybe during some of the breaks or lunchtime. I'd be happy to do so, time permitting. The other thing is this is a great example of how our group project could go. You know, if you decide you really want to do screen scraping for some future research project, maybe it would be wise for you to select onto a group that's using some form of screen scraping. But yeah, apologies for rushing through this. It's a real challenge to figure out how to teach to the skills of the class. Yeah, Jeff.
So I guess I'm more used to Python than R, and so like in my brain when I go to scrape a site, there's like the sites where you just request the URL and it gives you HTML. But then, like you said, there's sites that use JavaScript, and they put it on later. And in Python, I use Selenium.
Yeah.
But is there like an R, or is there Selenium for R?
There is R Selenium.
Oh. I should have.
So,
right,
no, it's fine. So Jeff's making this good point. If there's JavaScript, that means the user has to interact with the page in some way to produce the information of interest. And if that's the case, a nice way to handle that is through browser automation. So what you're doing here is essentially you're writing a computer code that says open up Chrome or Firefox or whatever, press tab twice, press enter once, and produce something. Now the trick here, so there's code that will, for example, tell you how to make your browser hit tab or space or whatever, any kind of keystroke. But our Selenium is really a neat package because it can automate fully, an entire machine, not just your browser. But in the case of screen scraping, it's probably most useful for that purpose. The trick with browser automation is to be able to learn how to use keystrokes to extract the information you want. That can be more or less easy. Some sites will throw little hitches that will disturb, let's say, 9 times out of 10 you need to press 2 tabs to get the information you want, but then the 10th time it's 3, right? And this can create a real challenge in browser automation, and many of the more sophisticated sites, such as like Google, for example, are aware of browser automation as a means of automated data collection and have taken these types of steps to slightly change the JavaScript each time it's reloaded, for example, using a different search term or something like that to get the data. Often, if the site offers some type of data like CSV and there's a download link, the trick is finding the download link and navigating to it with keystrokes and then extracting that information. But it's a great package. It can do a lot of things. We're once again in a legal and IRB gray area. Technically, it's a browser doing this stuff and not a computer script. 6 of one, half a dozen of another, right? Browser automation, however, can be used to mimic human behavior by, for example, introducing pauses in the code. But this also creates a really possible violation of the terms of service if you are repeatedly collecting data in this way. So I would love to have like best practices for you and firm tricks of the trade. I can tell you that there are many, I think it's fair to say, many examples of work that has done this and been published. Once again, I want you to envision the scenario where you've been collecting this data for multiple years, especially at great cost of time and coding, and then get a cease and desist letter that prevents you from publishing or in any way working with your data. So I think, in an ideal world, you would just pick up the phone and call the site you want to scrape. Like, hey, Google, can I take your information? No, right? I mean, that's most likely the answer. Even more disturbingly, though, is you usually can't get someone on the phone. This is a tough area, and tread lightly. Any other ideas or suggestions about browser automation?
Selenium's awesome. I was just wondering if anyone had or knew of any examples of people successfully using Selenium to produce research or to produce a published paper. Because I've used it in other contexts, but never for like a full project.
I think we might not know about it if it was done that way.
We've collected a bunch of data with permission of the site owners using Selenium, but we haven't yet published anything, and we most likely won't tell in the paper that we've used Selenium. We just say that we've collected this. Well, we most likely don't even tell that we've collected data. We say that we have this data set.
Now, let me also say, like, in some ways, this type of work, right? It's a new genre of work, digital trace data. And when you're writing up, for example, the methods section of a paper where you're describing how the data were collected, how many papers have you seen that use survey research that never mention, say, missing data or exactly which survey firm was used to collect the data, right? There's different conventions, different journals, different fields, and so on and so forth. I think the ideal solution is to provide as much detail as possible, but be sensitive, especially if you're able to put stuff in an appendix, to violating their or disrupting the patience of the reviewer. On the other hand, these are the upshot, and much of this doesn't get published either because of copy editing or whatever. It means that people who want to then reproduce the study don't know how it was collected. It's a real problem. So I do think erring on the side of explicitly explaining how the data was collected is ideal. Other thoughts?
Yeah, I was just going to point out the topic of Selenium in case anybody hits the bump with the JavaScript, that sometimes even if you're not interacting, you might have to use a browser rather than just reading the page, because with React.js, a lot of times the entire page is actually rendered with JavaScript. So you can, even if you just download the HTML, you get like an empty shell. It won't be filled in until later.
Yeah, absolutely. And I suspect it's a bit of a cat and mouse game. I mean, techniques. I mean, the structure of websites will continue to change, and Selenium and other programs would have to keep up. It's a pretty vibrant community of Selenium users online, though, so you can often find solutions to this type of problem. if you search around Stack Overflow or similar sites. Another alternative. This is very clunky, but another often a good alternative is to quote unquote scrape with Amazon Mechanical Turk. AmTurk is of course a migrant worker platform where you can. We saw yesterday one of the groups created HITs or human intelligence tasks, which is a list of instructions that you give to a worker somewhere for typically a relatively small amount of money to do some type of repetitive task. The trade-off here is that let's picture yourself wanting to collect information from a site that has both sophisticated JavaScript and an uneven structure, and at that, the type of information you may want to get requires some significant amount of intelligence, artificial or otherwise. The thought experiment I would encourage you to do is to think about the amount of time you might spend coding that versus the amount of money you might spend paying someone to collect that data. There may be a cost-benefit analysis that makes uploading a set of instructions, and in this case, data collection on Turk, there's a lot of templates that you can use. If you go on there and click new template, you'll see a data collection template. Typically the way it works is you upload a CSV file with a list of sites, in this case, you might want to extract information from. Then you're directed to a template that you then control that provides instructions about what type of data you want to collect. You then refer to a column in the spreadsheet that changes each time the human intelligence task changes, and then these get released onto the platform, and then people often very rapidly populate your data. Yeah, Kat?
This might be a silly question, but I've never used Amazon Turk before. Do you, if you're like crowdsourcing some of your data collection, do you have like IRB obligations if it's like potentially sensitive, or you have to get an IRB to be allowed to data source?
I want to hear from Jeff, but let me just say my entire experience with IRB, and I've been interested to hear anybody else's experience. Get them on the phone early and often. Don't treat them in a defensive manner, where you're, I have to kind of, navigate this labyrinth. Get them on the phone and say, hey, I'm thinking about this. What are your initial thoughts? Particularly if you have a good and generous IRB officer, you may get some preliminary feedback that helps you adjust your
to be more
approach.
specific, I'm thinking about like data that was technically anonymized, but can be like unanonymized by looking up like a court docket ID number in a site with a pretty good CAPTCHA block.
Yeah.
So if I wanted to have other people do that instead of doing it all myself,
Yeah.
because that data used to be anonymous, but I'm making it unanonymous.
Right.
I don't know if that's additional problematic.
Jeff, do you have?
Well, I was just gonna say when we did the IRB at Columbia, at least they basically wanted like screenshots of all the pages of our interface that we use for AmTurk, and they wanted us to put so like at least at Columbia they had like a set specific language for AmTurk that we put at the top of the page, and then the first page that the worker would do is agree on it before they could do anything. So
Stanford has a similar thing,
Yeah.
and I think as AmTurk is getting more and more popular, researchers or IRBs at various universities have like standardized templates.
so it's like pretty quick. We just like sent them the screenshots and they got it back.
I suspect it's a case-by-case basis, though, that depends on, you've already identified the issue as Git. I think we'd all agree
I
on
think
that.
they might be a little mad if I'm going to be like, hey, look up these murderers. I want the
Right.
victims' names.
Yeah.
There's no problems with that.
This is why we do ethics on the first date. Keeps coming and rearing its ugly head. Okay, so this is an example of one of those templates. If you've never worked with AmTurk, again, the TAs or I would be happy to help you get up to speed.